He has launched its Euclid telescope on a mission to produce an enormous 3D map of the cosmos. Euclid, which cost more than $1 billion, blasted off on a rocket from Cape Canaveral in Florida. It's hoped the project will improve our understanding of dark matter and dark energy. Researchers know virtually nothing about these phenomena, which appear to make up the vast majority of the universe. Euclid will carry out its work from an observing position on the opposite side of our planet to the Sun. Live now to Florida, where we're joined by Professor Bob Nichol, Professor of Astrophysics at the University of Surrey. He's worked on the Euclid telescope since its inception and was lucky enough to see its launch a short time ago. Professor, welcome to you. Just explain this phenomena to us and what this mission is hoping to be able to do.
Hello, everyone from Florida. Very hot here. It's hoping to give us the next bit of the puzzle to what this dark universe really is. So, as you alluded to, 95% of the universe is dark, it doesn't shine, and we have to observe it through other means. We know something about it, but we don't know all of the things about these dark substances in the universe. So Euclid really is the next step in our discovery of what this stuff is that makes up most of our universe.
And as you said, we can't actually see it. So how will Euclid take photos of this thing we can't see?
Well, we see it through its influence on other things. So we see it through its influence on things we can see. So it's using a topic called, or a methodology called weak gravitational lensing. And that's where the shapes of distant galaxies are perturbed as the light from them comes to us and passes through the dark matter between us. So we see it through its influence on other things. And if we get more and more galaxies, then we get a more and more accurate map of where that dark matter is and what it looks like.
And what will the knowledge that's gained from this mission, and what will it do in improving our understanding of our origins?
Well, we are fascinated about the universe we live in. We've ever since we've been able to look up into the stars, we've tried to understand why does the universe look like it is. In fact, the dark sky is an enigma to us through something called Doppler's paradox. So I think we've always had this lust for information of why the universe is the way it is. And then as we discover things, that sort of fundamental science, we turn that fundamental knowledge into more applied knowledge as things get more and more understood. So it's very hard to predict how these fundamental discoveries will help us today, but in the future, it gives us a foundation for more interesting technology, more interesting applications of our science.
So the telescope now to its final destination. Just explain what happens then and how quickly you'll start getting information and be able to analyze it.
Sure. Well, it was just announced here, which is absolutely fantastic to hear it. We've communicated with the satellite. So thumbs up. The satellite is talking back to Earth, which is a major milestone, as probably people may remember. That's always one of those very anxious moments when you fly a satellite and it doesn't talk back to you. But that's passed. Euclid is now talking to us. It's got a month-long journey until it gets to this place called the second Lagrangian point, where the James Webb Telescope is hanging out at the moment. And at that point, it'll go through about 3 months of just checking its instrument, taking the first images, making sure that they all are exactly as we expect them to be. And then it'll launch into a 5-year mission where it'll scan about a third of the extragalactic sky.
Bob, tell us what it meant to you to see it go up into space, the telescope. You've been working on this for 10 years.
Well, it's actually been 15 years, and today is a very special day as it's my mother's birthday. So I think she'd be very proud of my involvement in such a wonderful